electrons, the charges that move is a little men. The little men, the number of men that moves is called a current. So that's how many men that moves. Then your ammeter is like a register. It registers how many people pass per second. Then your potential difference or your volts, that is your energy. And I said let's make that your sandwiches, your food that you pack in every day in your bag. And then the voltmeter that checks your energy, I said is Miss Phsc or the teacher with the heart or whoever checks in on you. So what does she do? She checks your energy. Are you alright? Then the R, the resistors, are the periods that you have to pack in for the day. Today you have science, Afrikaans, English, blah, blah, blah. And then your cells is your home, where you get your energy, where you get your sandwiches. Right. Now, we are going to look at two types of circuits. The first one is called a series circuit. Okay, so I want you to draw what I'm drawing. Okay, this is not art class. If you draw this with a pen or a pencil, I don't care. If you draw it with a ruler or without a ruler, I do not care. Say again? We are busy writing in our books, yes. Not vibrating. The gas is just coming out. Alright. So, in our scenario here today, let's say you, the little man. So, in our story, it will always be that all of you, the whole school, is in our circuit, and everyone's circumstances is the same. Okay, so you all come from the same type of house, you all walk the same, you all get the same number of sandwiches, and. Okay, remember this is just a story. Yeah? And let's say in your backpack today, let's say you have 3 sandwiches. Okay, so 3 sandwiches means 3 volts energy. Okay, now when you pack in your sandwiches for the day, you check, okay, how must I divide my sandwiches? Today I have... Let's say today you have allo and you are going to have math. Okay, so that's in your planning for today. Okay, and then obviously register. So here you go. Let's just check in here in our cells. The positive line, there I say it. The long line represents the positive side and the short line represents the negative side. And we walk from positive to negative. Okay, so here we walk. That is your register class. Does register take energy? No. Okay, it depends on your register teacher, but it's not supposed to, right? You come in, they open the day for you. They say, remember this, and this is happening today. Who's present today? And there you go. Alright, so when you walk through it, everyone walks through it and it doesn't take any energy. Okay, so we say there that the current that passes through there, I is a symbol for current, is the total current that passed through it. Because everyone must pass through a register. Okay, right, then you come before allo, and just before allo, Miss Phsc checks in your bag. She checks what is your energy levels. Are you still sharp? Okay, so let's start with you. Before allo, how many sandwiches do you have in your bag? 3, because you haven't eaten anything, hopefully yet. Okay, then you pass through allo. And then after that, ma'am checks in your bag again. And I'm just going to make up a value now. I'm going to say after allo, you have 2 sandwiches in your bag. Alright, so she does a quick calculation and she says, okay, your volts, your potential difference. Difference means subtraction. So what was your potential here? 3. What is your potential there? 2. What is the difference in your potential? 1. So that reading on that voltmeter will be 1 volts. Okay, now let's just check the path here. When you came here, I said everyone passes through there. Why can they not pass through there? Or can they? Who is this? Miss Phsc. Can you pass through Miss Phsc? No, she's not a ghost. Okay? You cannot pass through a voltmeter. A voltmeter is just like a checkpoint. What's the volts here? What's the volts there? It's not a pathway. Alright? So you cannot pass through there. The current cannot split up there. Okay, everyone needs to pass through Allen. Alright, then you walk, you get just before math. Good Luano, how many sandwiches do you have before maths? 2. Alright, and after math? Okay, what's happening after math? You go directly home. Okay, now I don't know about your parents, but mine, let's say for whatever reason I did not eat my sandwiches that day. My mom is very furious because, like, how can I disrespect her food like that? Blah, 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 blah. Then I get that same sandwiches in tomorrow. Okay? She's not making new ones. So I better make sure I eat all my sandwiches at school and I come back with an empty box. I did sometimes. I said, let's trade. Okay, but that's not part of my story here. Okay. No, my mom actually stopped making sandwiches at all. What? She said, because she said I was disrespectful, so I had to make my own. Alright. So after math, you go directly home where you get 3 more sandwiches. So you better come back with an empty lunchbox. Okay. So your last checkpoint, you have 0. So what is your potential difference, your volts there? 2. Alright, so after that, you go home. Before you enter the home, how many sandwiches do you have? 0. When you come out of home, how many sandwiches do you have? 3. So what's the potential difference over the cells? 3. Alright, now let's just check. Does this make sense? Does it make sense that you need more sandwiches for math than you do for allo? Is math more difficult than allo? Yes. Alright, so you need more energy to pass through this one than you need to pass through allo. Okay, so you can see there, the current, the number of men, they're not split up anywhere in the circuit. They go round, round, round. But what did split up? Our sandwiches. I packed so much sandwiches for that, so much for that. So the sandwiches, the volts, the energy, that does split up. So our volts are 3 volts. Splits up, some of it goes there and some of it goes there. So 1 plus 2 gives me 3 volts. Okay, now in grade 10 and grade 11, we're going to assume that life is like this, that you go home with 0 sandwiches. But in grade 12, we're going to look at real life. Okay, is life easy at home? No, you get, alright, I'm glad to hear that. But when you get home, it's like, to help here, do the washing, do the dishes, alright, alright, so, you know, you cannot actually come home with 0 energy. You need energy for home, otherwise you won't work. So in grade 12, we say, alright, now we know that we actually need energy for home and how much do we need, blah, 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 blah. Alright, but that is in grade 12. In grade 11, grade 10 and grade 11, we're going to assume life is easy peasy at home. Alright, then the next one. Type of circuit, parallel circuit. Parallel circuit. Okay. Bless you. Okay. Let's say again that we have 3 sandwiches. Okay. So let's say again you have 3 sandwiches. But now for this day, you have, let's say again, aloe. But then you actually have a choice between math and math lit. Alright, now for our story, and I'm not discriminating against anyone, and I'm not saying this is true in life, but let's say even if it doesn't matter if you choose math or math lit, you will, when you finish school one day, make R1,000,000 a year. Okay, so it doesn't matter if you choose math or math lit, your success will be the same. What subject do you think most learners in the school will take? Math or math lit?
Math.
But it doesn't matter if you choose math or math lit, you will still make. If you choose math, you'll make R1,000,000. If you choose math lit, you'll make R1,000,000.
No, the reason I see math is because most children are pressured from parents.
Yeah, but your parents pressure you to take that so that you make more money in the future, hopefully.
Hopefully, yes.
But now I'm saying it doesn't matter if you choose anyone. You will make R1,000,000. So if you choose math, you will make R1,000,000. If you choose math lit, you will make R1,000,000. Which one are you going to choose? Math lit. Easy peasy. Why are you going to go through so much trouble to get the same amount? Okay. So no. The difficult level is not the same. Your outcome will be the same. Cloney, what did I say about Sotho? So, as jy iets vir hom wil sê, sê dit in Engels of in Afrikaans. Wat het jy vir hom gesê? Jy moet versigtig wees. Okay, so we know if we look at the human race, we know that we like to have things easy. We like to stand like this and say, give me, I don't want to work hard. Sharp. Say again?
You don't give us. I always ask, you don't give me.
You never asked me that.
It's a video.
Whoa, I haven't seen it.
It's training style. You never, it's a man at the moment, he asks for one hand.
And then? Hey, goed. Wat het ek gesê van Sotho?
Oh, you are lying.
No, ma'am, let's kill him.
Ja, asseblief, hierdie gaan syt. Okay. So ons weet, mense hou nie van hard werk nie. So tussen wiskunde en wiskundige geletterdheid gaan hulle kies wiskundige geletterdheid.
Ja.
Okay. So as die mannetjies hierso stap, waar gaan die meeste mannetjies gaan? Wiskundige geletterdheid. Alright, so we know that the number of men, let's just make this A and this B. Then the number of men that will choose to go through B will be bigger than the number of men that goes through A. Because it's easier. Okay, it's not that difficult. Now, in science, in this chapter, what do we mean with easier, more difficult, whatever? It means the resistance of B is smaller than the resistance of A. The resistance of B is smaller than the resistance of A. Siyabonga, what is the relationship then between current and resistance? If this one is bigger, then this one is smaller. Are you allowed to say the word indirectly? Inversely proportional. So we can say they are inversely proportional to one another. Alright, we're going to get to that, but our common sense tells us that. Okay. A resistance. Can be resistor or resistance. Who's my water boy in this class? Please, sir. Yeah, I have a water boy. Right. So, what's happening here is the little men. Okay, no, sorry. So, before you start the day, you say, okay, I have 3 sandwiches in my backpack. I'm planning my day. Alright? When I plan my day, I have to go to Allo, it's compulsory. Do I have to go to math and mathlet? No, I have a choice. I get here, I have a choice. I either go through math, then home, or I go through mathlet at home. You can't say I go through mathlet and then math. You can't go back into the current. Okay, so you plan your sandwiches for 2, Allo and math. Alright, so my sandwiches will split up into 2, Allo and either math or mathlet. It depends which one I choose. Okay, so here the little men walk. Do, 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 do. Everyone passes through register. And then everyone passes through Allo. Yes.
Doesn't register take a sandwich?
No, it doesn't. It's not supposed to. It's supposed to be easy peasy. Except if you make your teacher to be crazy.
Mega.
What?
Mega.
Murder.
Mega.
What's Meryl? Is it teacher from primary school?
No, but I really say if you make it
Oh.
please.
Okay, what's the word?
It's a synonym. Mega.
Meryl.
It's an English term.
Mega. Like you're Marilyn. Going please. Mega.
Did your English teacher teach you that?
No.
Is it not a slang word?
Eh?
No.
How do you spell it?
Math.
Marilyn. Like Mag.
M-E.
M-E-R. You just say Mega. M-E. M-E-K-K.
Mega, you write like this.
Mecca.
Not Mega. Mega.
Mega.
With the car.
Yeah, but without the R. Yeah, Mega. Mega.
Look that word up.
It's the modern one, this one.
Yes, it is modern.
This one.
Oh, we can go on. We will get back to you. All right. So, Rory-san, before Allo, how many? Thank you, Siyabonga. How many sandwiches do you have? 3. All right, and after 2. So your potential difference, your volts there will be 1 volt. All right. Now, Zara, your choice. Do you want to go to math or to mathlet? Math? Oh, really? Okay. So there you walk. Do. When you get here, you have a choice. Either math or mathlet. And Zara chose to go to mathlet. Before mathlet, how many sandwiches do you have? 2. Zara. 2. And afterwards? Why? Because you're finished and then you go home. Right? So you have 0 sandwiches left at the end. So what's the potential difference of volts there? 2. Okay? Now, tomorrow, you choose math. Okay? You don't have a choice. I'm telling you, you choose math. Did I call you? Oh, sorry, Courtney. Okay? So you choose math. Alright. So can you see when we got here, I did not say, Zara, you choose mathlet, and now Zara, you choose math. I said a different charge. So a different man, a different electron man with its own number of sandwiches chose a different path. So the charges, the little men, splits up. Okay, they split. Okay, here it goes. Now again, Courtney. How many sandwiches do you have before math? 2. And after math? 0. Why? Because you go directly home. Alright, so can you see that if you choose the math path, you have 2 volts. If you choose the mathlet path, you have 2 volts.
So you don't have to write this and that.
What?
You don't write the message if you choose with the message.
No, you have to write down both. But you think this little man choose here, this little man choose there. Alright, so If you choose math or if you choose math lit, doesn't matter, you have 2 sandwiches, 2 volts. Okay, when we get to the total volts, okay, do we say 1 plus 2 plus 2 gives me 5? No, because you only had 3 sandwiches. You have 1 plus 2, or you have 1 plus 2. Okay, you can't say 1 plus 2 plus another 2. So when you are in parallel, your volts will be the same. Your volts will be the same in parallel. Say again? You must highlight them to be parallel. Blue, blue. What else did I want to say? Here you get together again, you say hello, how was math lit, and everyone walks back home. Okay, I just want to ask again, do the current split up equally here? No, it depends on the resistance. If this has a higher resistance, less men will choose that path. If this one has a bigger resistance, a smaller resistance, more people will choose that path. Yes, Ntando? If they are equal, how do you think it will split up? Equal. Alright.
So then, in a test, you go to the lower one.
Yeah, the lower resistance one. You. But remember, in a test, you're not going to tell me I choose the lower one. I choose to go to the lower one. Ne? You want to say the bigger current goes through the one with the smaller resistance. This is just a story to help you understand. Alright, then we are back to your notes. I'm very glad. Okay? And I want to go first to page 2. On page 2, there is a class activity. Okay. And I want to quickly do that activity. Just going to check here. Alright. So this is the simulation that we did last week with the friction. Alright, so the same website, but just another simulation where we have circuits. Okay, so you can set up the circuit. You can see here, I can choose either we see the actual thing like a cell or whatever, or we can choose the symbols. But some of the symbols do differ, like the light bulb symbol differ from ours. Ours is a circle with an X through it. Okay, so that's why I don't choose that. You can see here you can choose lots of things. Coin, paperclip, dollar bill, eraser, dog, hand. Okay, just to check, does something conduct electricity? Do you think a dog will conduct electricity? No. Alright. And do you think a pencil will? Yes. Alright. Anyway. Okay, so we have that there, and then you can see in your where's yours? Yes. No, it's not that one. Alright, so you notice we're on page 2. We're busy with activity, and we are just going to check how we connect cells. So in the first part, we have one cell in there, and then we have 2 cells, and then we have 3 cells in series. And then we need a voltmeter reading, and that voltmeter reading will be over the switch. Okay, so you can see there, if I close the switch, the light bulb shines a bit. Okay, not a lot, but it does do a bit. I just want to check, can I make it? Okay, no. Yeah, that's about it. Okay, right, so there you can see the light bulb shines a bit. Now I'm going to bring in the voltmeter. Okay, can you see the voltmeter is who? It's Miss Phsc. So she's not part of the circuit. She just touches different points in the circuit. What is it there? What is it there? All right. Now in our battery there, in our cell. This is the part that has a little thing sticking out, and this part is flat. The part that sticks out, is it positive or negative? Positive. Okay, so that's the positive side, that is the negative side, so the circuit goes like this. Now I want to know the red conductor, the red part of the conductor, is it the positive side or the negative side? Positive. So that's why, oopsie, this one will go there, the positive side, and this one goes at the negative side. Okay, oopsie, let's just put that there. All right, so when the switch is, what must your reading be first? The open one. Look at the heading. What does the heading say? Switch open EMF. Okay, we're going to get to what does EMF mean in a moment. Okay, so when the switch is open, what is the reading? 1.5. So you write in there 1.5. 1.5.
Switch on.
With one cell, we have one cell there. All right, and then when the switch is closed, what is the reading? 0.
Ma'am, what will happen if you put like a battery when you stick it to a tub?
For a long time, it will fizzle. Depends what battery, but it will taste weird, I think.
It won't do anything shocking.
It can. What, do you have done that before? That's why you're asking. What did you experience?
No, I haven't done it.
I think you've done it before.
No, I think I'm asking because the battery has one.
A battery has acid in it. Yes. All right. Okay. Now I have 2 batteries in there, 2 cells. Okay. When the switch is open, what's the reading? 3. When the switch is closed, what's the reading? 0.
Then how's that possible?
I was waiting for someone to ask that question. All right. When the switch is closed, all right, your little man walks. He gets 3 volts, 3 sandwiches. When he gets here, has he used any sandwiches? No. So how many sandwiches does he have? 3. When he goes through the gates of the school, how many sandwiches does he have there? 3. So what's the difference? 3 minus 3 is? But now what happens when it's open? Now, okay. Now this part is my story is a very elementary story. Elementary means lower grade. Very easy peasy. So it doesn't make. It's not true for a circuit really. Okay, when you look at circuits, really, there's no little men walking with sandwiches, going through class, thinking how many sandwiches will I use here? Not like that. Okay. Then charges move very fast. Okay. So when the switch is closed, it just goes. So when you want to stop the charges mid-air, it's as if the charge is there. All right, has already actually gone through there. Okay, so you can't actually stop it in time because the charge just goes too fast. All right. Now, when you open the switch, it is like you close the gates of the school. Okay, you say no one is allowed to pass through. So the people still coming to school, they're a bit late, they are here. And the people there is already in school. Okay, right. So the people that walk in here, before they get to the gates of the school, how many sandwiches do they have? 3 sandwiches. The people that are here, it is like they have gone through the whole system. Now they wait to get back home, but they can't because the school's gates are open, so they can't go back home. So they've gone through all of the periods, all the sandwiches are finished, and now they're waiting. Okay? But it's electrons, it's negative charges. Right? What do we know about negative and negative? They repel. So all of them are waiting there, they can't go back home, and now they repel, they spread out. So the charges on this side has how many sandwiches? 0. The charges there has 3. So what's the difference? 3 volts. Okay. That's the best that I can explain it in sandwich terms. Say again? It's not gonna what at all?
It's not elementary.
Well, really? You think so? I'm glad in thunder. All right. Then we're gonna go to 3 sandwiches. Three sandwiches. 3.
School bag.
Not 3 school bags. 3 homes. But if you want to say school bags, go school bags. All right. Sorry, I just want to make those volts 1.5. All right. So you have 3 cells. How many sandwiches do you have? 4.5. And then when you close it, how many do you have? 0.
Are you going to give us the thing? I know what's it called, the voltmeter.
I'm going to tell you, if your voltmeter is over the switch, what will the reading be? Because you can put your voltmeter over the light bulb. You can put your voltmeter over the cells.
So
On
how
the
are we gonna know
cells.
the reading?
What do you
It depends where you put it.
so what if you put it
And then, if you put it
on the cells?
on the cells, I don't think the cells conduct. The cases does not conduct. On the bulb, a bulb does not conduct. Glass does not conduct. Yes.
How does a voltmeter look like in real life?
In real life, you get different ones. The voltmeter.
And image is also like that.
Exactly, it just says ammeter.
From the olden days or now?
Does this look old to you?
Yes.
I bought it 2 years ago.
1980s.
Man, that one.
This is a new one. We still use it, but they don't use it in
It's all
electricity. They use
There's no electricity police.
one like this.
Oh,
Man,
modern one.
A
what's
bit
that
a
thing?
modern one.
Man,
But I don't give learners this one because then you'll break it.
man, what's that thing like when you check if your box has electricity?
I think they use one similar to this.
But it's like a pen, yeah, then it just.
Yeah, so here I stick in this
Okay, okay, I'm taking jump.
and then I measure it with a point.
Yes, but there's newer ones now.
Yes, obviously there's newer ones.
What do you call that one? It's called...
This is a multimeter.
No, man, it's kickstart, you know? What do you call it? It's jump start. What do you
Well,
call it? The cable
For
truck.
like cars.
just cables.
Jump ship.
Jumping jack. Right, then we have your second part of that activity is where we have cells. First one cell, again one cell would be 1.5 and 0, 1.50. Are you writing down 1.50? For the second part of that activity?
This one.
Yes? And then we are going to have 2 cells in parallel. Just give it me a moment. Okay. Right. So when the switch is open, what will the volts be? Wait, just let me check. Wait, 1 minute. The switch is open, what's the volts? A switch closed? 0. So why is it not now 3? Because we have 2 cells.
The pressure.
It chooses which subject it goes to.
Okay, remember, there's not subjects. This is your home. So this is like when you have parents that's divorced. Okay? You can't choose to go stay at both homes at one night. Alright? You guys say, right, let's go to this one. I get 1.5 sandwiches. You can't go back and get more 1.5. Get 1.5, you pass through the day. Then you go to the other house, 1.5. You pass through the day. 1.5, 1.5. So there's like 2 separate homes.
Divided.
It's divided.
Ma'am, I
Yes.
feel like you had an open switch this side and you had another open switch that side.
Then it will still be 1.5 because you can't pass through that one.
If you had an open one and a closed one,
1.5.
Because it's open.
Yes. All right, back to your notes. So here you filled in. This was 1.5, 3, 4.5, 0, 0, 0, 0, 0, 1.5, 1.5.
The
Then?
unit.
Volts. Alright, so what did we just look at here? We looked at cells in series and cells in parallel. Okay, so what is the characteristics of cells in series? The more cells you have in series, the greater the ability or the potential of the battery. Okay, so we saw that we had 1.5, 3, 4.5. So our volts increase, the ability becomes more to supply a current, and thus the bigger the current that flows through it, because you get more sandwiches. You can walk faster. Right? Whereas when you have cells in parallel, we saw that it stays the same. Okay? So the more cells connected in parallel, sorry, I'm just going to get there, but they cannot supply a bigger current. The current stays the same, but the cells will last longer. Okay, so what do we mean there? What does it entail? So here you get, let's say your house has 1,000 sandwiches and then it's finished forever. Okay, so if you take one here, 4.5, 4.5, 4.5 every day, you will last, I don't know, X amount of days. How many days? Someone? Relo? 1,000 divided by 4.5. How many? How many days? Okay, 222 days. You will have food and then it's done. Just wait a minute. But if you just have 1.5 sandwiches a day, 1.5, how many days will you live? 1,000 divided by 1.5.
454.
Did you do it?
No,
How many? 1.5.
okay.
600 days. So if you take a lot of sandwiches in one day, you will last shorter days. If you take 1.5, shorter amount of sandwiches every day, you will last long. Sharp. You don't have homework.
Thank you.